So here we're going to learn how to make a dot plot. They're very easy to make. They are a form of displaying quantitative data. They're basically like a histogram. You're using dots instead of bars, but effectively it's the same. I like to work with real data as much as possible. These are actual placement test scores for my students back in 2009, so 5 years ago. And just so you know, this was out of 21. Okay. So I had 2 sections of Algebra 2 back then. And just by looking at numbers, I can't tell a lot about what's going on here. So we make a picture. To make this dot plot, I need to know what the minimum score is and what the maximum score is. So tell me, what's the minimum score between the 2 classes? 5. And the maximum score? 20. Let's look at how many tick marks I've been given. I need 16 to go 1 unit per 1 tick mark. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh yeah. So I'm just going to start at 5. I just need to cover both classes. And I can go up to 20 since that's the highest score. And this is extremely simple. You are going to place a dot for every value in the data set, stacking the dots if there are more than one. Try to keep the dots equally sized and equally spaced. So the first student here in period 5 got a 10 on this exam out of 21. There was no partial credit. It was all open-ended. And then the next person gets a 6, or got a 6. We have 3 11s next. It's like the band 311, huh? And then 13, 12, etc. So make your dot plot now. Once you're done with period 5, you can put period 6 on top. 10, 9, 14, 10, 18, 12, 19, 14, 6, 8, 10, 17, 11. You could distinguish period 6 from period 5 by using a different symbol. I'm not going to do that in this case. I'm just lumping all my students together into one graph to get a sense of overall what's going on. So for the first person in period 6, 13, I'm just going to put that right on top of the period 5, 13, using the same symbol. 11, 8, 15, 10, 7, 5, 7, 12, 9, 14, 20, 13, 9, 13, 10, 14, 7. Okay? Voila, a dot plot. One of the things I commented on your Chapter 3 quizzes, label and title. So I will title my x-axis placement test score. And then this graph is distribution of Algebra 2 placement test scores, Johnson, 2009. Let's just corroborate. 1 5, 2 6s, 3 7s, 2 8s, 3 9s, 8 10s, 6 11s, 3 12s, 4 13s, 4 14s, 1 15, no 16s, 1 17, 2 18s, 1 19, and 1 20?
Yes.
Confirmed. Now let's comment on the distribution using the cues that we're familiar with. This is a review, so I'll call on random people. Yes, sir.
On your test, say there's 2 groups, but then you add a third in your actual question. So talk about it after.
Okay, a random person is Eva. Tell me about the center of this distribution, Eva. Around 10? Yeah, I think that's reasonable. This is centered around 10. If you're going to pick just one number to describe a distribution, it's going to be the center. So that tells me overall how my students are doing, and I can easily compare that with another class. Not a great score, right? For a test that's out of 21. But this is not atypical. Every year in the math department, we would be amazed at how low the scores were on the placement test.
What's the placement test?
Placement test. This was taken mid-year, January. Okay. And it's on material that they had. Some hypotheses for why the grades are so low. The students are not used to a cumulative test. No partial credit. It's open-ended, no partial credit. Students may be overconfident because they're told that it's a review of topics, so they may think that they do not need to study. We tried to communicate how important the test is, but that might be ineffective. So a variety of hypotheses. Next, Dan K. The center, not good enough. I need to also know how spread out my data is. So tell me about the spread. Yes, the scores range from 5 to 20. Quite a lot of variability in this data. Just saying 10, not enough, in my view. If you wanted to calculate back to the center, if you wanted to calculate the exact median, you could. But I think 10 is a good figure. Next, Dana, tell me about the shape of this distribution.
Generally symmetrical.
Okay.
With a slight skew right.
Yes, I agree. Skewed to the right. Question?
Why is it skew right and the tail on the right?
That's the convention we use.
Oh, right.
Okay. So if you were to draw a smooth curve over this, you would notice that the tail is longer on the right. Therefore, it's skewed to the right. That tells me that the bulk of my scores are on the left, and that I have a small percentage of scores that are dispersed on the right. They may be removed, but they're further away from the center than the scores that are to the left of the center. It's hard to articulate skew in my experience. Kevin, what's the other thing we talk about in shape other than skew or symmetry? Yes. So tell me about peaks here.
There's like a small peak at 7 and 18.
Yeah, maybe even 18. Yeah. So our primary mode here is easy to distinguish. It's 10. That's the most frequent score, most common score. However, I would point out these possible secondary modes. One centered at 7, one at 13 to 14, and then another at 18. They may be due to chance, but I'm still going to point them out.
So would you refer those as like the 7 and the 14, 13, 14?
Secondary modes. Question? Yes?
Why would you consider 7 a peak but not 9, which is also 3?
You're looking for things that are higher than their neighbors. Yeah. Okay. So 7 is higher than its neighbors, but 9 is not higher than both of its neighbors. Okay. So I'll say possibly multimodal. I say possibly because there's two reasons for that. You can have modes pop up just due to scaling, like your choice for bin size and also where you start your graph. And you can have modes show up due to chance, like if you're considering this a sample from a population. So, as I was saying before, your primary mode is definitely at 10. And then possible secondary modes at 7, 13/14, and 18. Yes, sir?
For it to be multimodal, the peaks have to be like not due to chance. You just said possibly multimodal.
I don't know if they're due to chance. So I'm going to say possibly.
So if the peaks occurred due to chance, are they not multimodal? You get what I mean?
That's a good question.
No.
I think we have to establish, is the adjective referring to the graph or to what's actually there?
Okay.
I think that most people would interpret it as with respect to the graph.
So every time you see a peak, basically multiple peaks is always multiple.
It's whatever you see.
Okay.
Yeah. Good question. Yes, sir.
I was just wondering, because like, you start with one.
You could certainly start at 1. I don't think it's necessary. Yeah. Any other questions so far? Okay. And the other category we want to make sure to discuss is outliers. So you might remember the acronym CSSO, Center, Spread, Shape, Outliers. A random person is Ben. Give me a comment, please, about outliers in this distribution.
Well, there does not seem to be any particular outliers since you have, since it's possible multimodal, especially where, since 18 is perhaps one of the multiple modes.
So I'll stop you there. I would say the modality is independent of the outliers.
Okay.
So even though you have an apparent cluster at 18, those could be considered outliers.
Okay.
Yeah.
I suppose, I guess is it possible to have multiple outliers all in one group?
It is possible to have multiple outliers, yes.
So then the people within 17
Could be considered outliers, yeah. So there are no points or point that are very far away from the rest of the distribution. However, I would point out these values here between 17 and 20 as being outlying values. I'm definitely going to investigate these students and see if there's a commonality, make sure that these values are real, because these values are going to have an effect on the statistics that I calculate. Okay? Yes, sir?
Would it be wrong to say that there are no outliers?
If you're going to say there are no outliers, then you better back up your statement. Yep.
Would you say that 17 and 20 like relatively? Because when I saw the graph, I also thought that there were no outliers, but
Mhm.
then when you consider, are outliers just numbers that could skew the statistics?
That's one definition of them. Let's take a look at the book's definition. Chapter 4. The book defines an outlier as extreme values that don't appear to belong with the rest of the data. They may be unusual values that deserve further investigation or just mistakes. There's no obvious way to tell. Outliers can affect many statistical analyses, so you should always be alert for them. So even though there is no objective definition of an outlier that everyone in the statistical community agrees to, it's still very important that you understand the concept of an outlier and the effects that outliers can have. Yes?
But I feel like because there's already 5 students in the 17 and above range, it's a significant number of students. It's not just like one person on the end.
Uh-huh.
There's a cluster.
Yes?
So could you say, I don't know, like limit, like say the entire cluster is an outlier, and that it's unreasonable to assume that like they belong in that set of data. I think it's very reasonable to think that people could pass the replacement test for.
Okay.
Could that be like your claim if I said there's no outliers?
Sure. Yeah.
Would you still count them as outliers if there are 2 students at 16?
So that's a good question. If there were students at 16, would these still be outliers? Maybe not, because now they're no longer removed. There's no longer a gap there. I would still comment on the skew, though. Okay, skew and outliers can overlap. Absolutely. Okay.
Sorry.
Yes.
But don't you put the skew in the shape of
Mhm.
the outliers?
Mm-hmm.
But you can also put skew in the outliers.
Now, outliers, even though they're related to skew, I would say they're a separate category, because you can have skew and no outliers. But if you have outliers, you have skew. Okay? So my response here is going to be the scores from 17 to 20 could be considered outlying values. Because of the gap at 16. But they aren't far removed from the rest. So just in summary, if you're not going to consider 17 through 20 outliers, then state why, and at the same time, understand their effect on statistics. For example, the mean. These values here are going to drag the mean up. Good, moving on. Now we're going to compare the two classes, see if they're any different. When you're comparing two distributions, you want to make sure that your scale is the same. It doesn't have to be the same as this aggregate graph. It just has to be the same vis-a-vis all the comparative graphs.
Mr. Johnson,
Yes, sir.
would you want to include number 21 on there because that's like the total?
I don't think it's necessary. It might be advantageous if you are trying to express to the reader that these are the absolute possible range of scores. That would be fine. Bless you. Okay, and then dot away. And then period 6 goes below it. Okay? Now let's compare the class's performance. Or performances. Daniel Cho. What's similar? What's different?
The first difference, I guess, is the modes, like the period period 5, 10 would be the primary mode, whereas period 6 there are 2 primary modes, I think, 7 and 13.
Yes.
And the similarity would be that it's usually like
Agreed. Tell me about center and spread, please.
the center of period 5 is probably going to be 10.
Oh.
11 or 10.
Yeah, 10, between 10 and 11, probably.
And period 6 is probably 11 or 10.
Yeah. Center's very similar.
Yeah.
How about spread?
Spread is different in that the first class is 6 to 19.
Mhm.
Whereas period 6 is 5 to 20.
Agreed. So slightly larger spread of scores in period 6.
Yeah.
How about outliers?
For the second period, for period 6, number 20 would be your outlier.
Mm-hmm.
And for 25, arguably 17 to 19. Oh, and period 6, number 5 is probably. And for
Yeah.
25, 6.
Yeah. So the one that we can see is the furthest removed between both classes is this person who got a 20 in period 6. They're the king of period 6, or queen. Not sure. Period 5, you could consider the people getting 17 to 19 to be outlying. You could also consider these values on the low end, the person who got a 5 in period 6, and the 2 people who got 6s in period 5 to be outlying values. Okay? But not a big difference in the overall performances between the two classes. Period 5 scores are more concentrated around the primary mode, which is interesting. Period 6 is more of a uniform distribution, more flat-topped. Not sure why that would be, but it's there. Okay? So we'll say centers are about the same. Between 10 and 11. So overall the classes did roughly the same. Period 6 has a slightly wider range of scores. 15 versus 13. Both are skewed to the right. Period 5, one could argue, is unimodal. You can get into a multimodal discussion there, but it definitely has the more distinct primary mode versus period 6, which is more uniform. Period 5 appears unimodal. Ode at 10, whereas period 6 is more uniform, more evenly distributed. And both classes have what could be considered outliers. For example, 20 in period 6. Okay, any questions? Yes?
You just move it a little to the left.
Again, any questions?
Taylor to the left. I mean right.
So that's how you make dot plots. Now what I do is I try to find reasons for what I'm seeing. I expect test scores to be unimodal and symmetric. When I see deviations from that, I question what's going on. These students here, I want to know more about them. Why are they removed from the rest? These could be former honor students. That's certainly a possibility. Or these could be students that we would recommend for honors based on their performance. And then down here, I can see that there's really not a big difference between the classes. So I don't have a reason to believe that there's something about period 5 that's making them significantly different than period 6.